Good morning, everyone. So, today, as I said, we're going to put a little pause to ensure that we understand where we are coming from in algebra. Let me show you on screen. Yeah, let me show you.
For like the 9, one of the questions in book 2, the 9J, I think the 9J, the 9J one. I'm not sure if I'm doing it right, but I think I'm doing it right, but I'm not sure like I fully get it.
So what's gonna happen, Jaziel? I'm not gonna grade this one, but just send it to me now so I can give you some feedback on it. All right?
Yes, sir.
All right. So what's gonna happen now, Jaziel? We're gonna go over the different laws that we went through, right, and make sure that you understand what you need to do. All right. Let's go to the first law again. Can everyone see this? Can everyone see A to the M times A to the N? All right. I'm gonna select each student, and you're just gonna tell me, for example, what does it mean? All right. The reason I can't scroll over just here is because it shows the answer, but I want you to give me the answer before I scroll over. All right. So let's go to A to the M times A to the N. What's the rule there? When you multiply two bases with this, two numbers with the same base, what do you do to the powers? Add them. Perfect. So we have A to the M plus N. Excellent. Now let me select PL. If we have A to the M divided by A to the N, what was the rule?
You subtract.
Subtract. Excellent. Now this is going to be a little bit difficult. Khalil, if we have A to the M in a bracket that is raised to another power, what do we do to those two powers? One inside and the one on the outside. What do you do?
Or do we add them?
Well, no. And here's why. Do you remember what I said? When you have a number outside of a bracket, what do you do to the number inside? You
multiply them.
Exactly. So if you have a power, right. So if you multiply, say if you have a power inside of a bracket, guys, such as M, then you have another power on the outside, you multiply them. So that will give us A to the M times N. Everybody understand? All right. Let's go to the next one. What do we say happens when you have a base raised to a power of 1? So for example, what happens when we have 2 raised to the power of 1? That value is? No. 2 raised to the power of 1 means we only have how much 2's? So look, if we have A to the 1, what does the rule say? All right. So, right. So we're only going to have 1 of that value because we only have 1 in the power. So in other words, we're going to have A. So if we have A to the 1, that means we have A. We're going to write this out in a moment. Last one. If we have A to the 0, right? What does that mean? We have only nothing. So we really just put 1. So if I tell you that I have 5 raised to the power of 0, that meant I only really have 1 number because there is no 5, which is a 0. All right. So we're gonna write these out in statements just to ensure that we have, and then you're gonna write the examples. So let's write some statements. So the first law of indices, put in bracket multiplication. You started taking these notes earlier, but we didn't entirely write sentences. So we're going to write some sentences now. So we're going to say the first law of indices, put in bracket multiplication, says that when you have two numbers that have the same base, and let me ask Harry, in this number A to the M times A to the N, what would be the base?
Wait, sir, what did you say?
If we have A to the M multiplied by A to the N, what would be the base in this calculation?
The A.
Excellent. So we're going to say the base is A. So if we have two numbers, right, that have the same base, for example, A, right, and they are being multiplied, we add the index. We add the index. So if I told you that I have X, put a quick example, X to the 1 right, multiplied by another x, or should I just say x? Let's just put x. If I say I have x times x, one smart person tell me what's gonna be the value here? X squared, correct? All right, let's go to the next law. The second, my bad. A moment. Should really disable that. My bad. Okay. I think I have some statements on it. Right. Okay, good. Okay, so we're gonna go to that PDF in a moment. So we're gonna say now the second law of indices, right? Division says that when you have two numbers, it's technically the same statement as above, but we're just gonna change something in there. When you have two numbers that have the same base A and they are being divided, we subtract the index, right? So if we have x divided by x, right? Can anyone tell me what the answer would be? If you only have x to the 1 divided by x to the 1, what would be the new value? Can you repeat? Right, so we're gonna have is equal to x to the 0. Right, and we can go. So the thing about it, and the cool thing about it, guys, is that if you memorize this table or just memorize the first 4 or 5, you in turn can always solve your indices. Because here's what happens: this x to the 0 is observing another rule, which is the fifth rule, right? That says whenever you have x to the 0, that's in turn really just saying 1, right? So the rules themselves are transverse. You can use them in different cases to really find your answer. All right, we're gonna say now this the third law. My bad. The third law. The third law of indices. Right? Brackets. Says that when you have two indices, we can just say two index, right? And then you put in bracket, one is in a bracket and the other is being raised to it, such as, let's put an example. All right, we're gonna say 10 raised to the power of 1, all in a bracket, raised to the power of 2. Right? So what happens is that something's gonna happen with this. We say they're gonna be multiplied, right? Comma, we multiply the 2 index. So I'm gonna highlight the key terms for each law. So I'm gonna highlight multiply for the third, subtract for the second, and then add for the first. Excellent. All right. Let's go into the fourth law. All right. The fourth law of indices. All right. This one is saying power of 1 right, states that when you have a value that is raised to only 1 as a power, the value, oh, my bad guys, I don't know what happened there. The value, the answer is the value itself. An example, I'm going to say, let's use the 10 to the 1 that we just had. 10 to the 1. Because there's only one of the 10, the answer would just be 10 itself. Right? Then the fifth law of indices, right? This one now we're going to call the power of 0, right? States that when you have a value that is raised to the 0 power, the answer will just be 1. Input number 1. There we go. Example, 200 and let's put 20,900 raised to the power of 0. It's very magnitudinous number. All right, there we go. Let's put it. Excellent. Let's put to the power of 0. That gives us only 1. Does that make sense, everybody?
Yes, sir.
So we're only going to learn the first 5, right? The 6th and the 7th, right? For example, this one, these are a little bit advanced for your level because you won't necessarily need them right now. So let's just focus really on what we need to know. So we have one more to go into. I mean, the 6th one, then the 7th and the 8th, we won't go into. So the 6th one is one you're going to be using. So the 6th law of indices, which is the final one we're going to be looking at. The 6th law of indices, right? Fractional power states that when you have a fraction, and it can be improper or proper, it doesn't have a preference, improper / proper, right? Essentially what happens is that the power that the fraction is raised to is distributed to each term. What law do you recall when you hear distributed? Anyone remembers? There are 3 main laws: commutative, the associative, and the the distributive law. Recall the distributive law. But we're gonna go again, as I said, into each topic that we learned previously, like one more time, just to ensure everyone is understanding. So we're gonna say recall distributive law, and that's what we're gonna be going through today. Recall distributive law is raised. So if I told you that I have a fraction, for example, 9 divided by 11, right? All raised to a power of, all raised to a power of 2. All raised to a power of 2, right? I want one person to tell me what's going to happen here based on the definition. Let me choose David, right? David, are you there? Yes, David. Based on the definition of fractional power, 6th law of indices, I have a fraction, right? And it says that the power is going to be distributed to each term. What are the 2 terms in this fraction? Let me zoom in for you. So What two things do we have in this fraction? What two numbers? Are you there? 9 and 11. So those are our two terms, 9 and 11. Right. Let's put a pause now. It says now that we need to distribute that power to each term. So tell me what will be the new value for 9? Or in other words, express 9 with the power 2. So you're going to say what? 9 raised to the second power, right? But I wanted David to get it. So we're going to say...
Oh, sorry.
No problem, no problem. So we're going to say 9 raised to the second power divided by 11 raised as well to the second power. All right? This is what we call distributing now this power to each term. You essentially put it on each term when you expand it. And then we can work it out after, but that's not necessary because that wasn't really a question for you to solve. All right? Okay, so those are our 6 terms that we need to know. So watch over the video when you finish, right? Recall them. The summary is going to be on page 29, right? And then that will be the end of that. Everyone take the notes here. Are you guys finished with the notes?
Yes, sir.
All right. Okay, good. Okay, good. So now, next thing, as I said previously, is that we're going to be going into distribution law. All right, so look at this table for me. Scroll down. Okay, so if you remember, last class we looked at the division on algebraic terms, right? Where I gave you some terms and you're supposed to just calculate it for homework. I still want you to do that. So after class, I'm expecting some submissions so I can give you feedback. What we're going to be working on, as I said, is the... One second, let me just look for it. Here we go. All right, we're going to be working some examples of the distribution law. All right? I'm not finding it there. Let's go to yesterday's date because I think that's where I put it. Okay, good. Found it. Okay, so if you go to page 222 in the book 2, page 222. Everyone there? 222, 223, right there. Page 223. Let me put it right here. Page 223, volume 2, slash, my bad, slash book 2. So we're going to go into, again, what exactly we mean by when you distribute something. All right? Let's write a definition quickly. So, if we have a value like, for example, 9 into, my bad, let me just erase that. If we have a value such as 9 into 10, let me zoom in, right? What would you do to solve this? To solve this, what would you call it? You what? You put the 9 and multiply this 10, correct? Anyone remembers that? That's right. So, to solve this question, the special type of bracket called parentheses, write that for me, parentheses, shows us that we need to multiply, right? So this bracket, this type of bracket is called parentheses, right? That's what we use to identify when we need to multiply, because it's not all the time you're gonna get explicitly, oh, 9 directly multiplied by 10. Sometimes the exam will use their head and just put it in bracket. So we're saying this type of expression, 9 times 10, is the same thing. My bad. It's the same thing as 9 bracket 10. Nine bracket 10. Okay. All right. Good. Good. Let's go into the definition now. The distributive law is used, right, to remove brackets right, each term within the bracket is actually being multiplied by the term on the outside of the bracket. Okay? Okay, good. Let's fix this correction right here. All right, excellent. So let's do a quick example. What if we didn't have numbers? Because remember, in the previous classes, we've been working with algebraic fractions, right? And let me quickly remind you what algebraic fractions is. It's simply where you have symbols along with numbers in your calculations. So say, for example, you had 5a divided by 2. That's an algebraic fraction. So when we look at, for example, 9 times 10, what if we didn't have 9 a number and 10 a number? What if we had algebra like A, B, and C? Let's see how we would expand those types of brackets. So we're going to say now expanding, right, brackets, algebraic brackets using the distributive law. It's a very important topic. We'll look at some examples. Right. So, first one, let's look at A times B. Let me zoom in. Right. A times B. What action is being done here? Is it a division, a subtraction, addition, or a multiplication? Anyone? Multiplication. So in other words, we're saying A times B, correct? A times B. Right? So this is half finished, and here's why. Right? When you say A times B, you can rewrite it another way and still have the same multiplication being done. So there's 3 ways to write multiplication. There's the parentheses, as I stated above, right? The multiplication sign, or you have just the 2 digits or letters together, and that means multiplication. That makes sense? So if you say, oh, AB, you really mean A times B. So let's write that. There's 3 ways to express multiplication. There are 3 ways to express multiplication. Right? Parentheses, multiplication symbol, and then, right, 2 values attached. So if A, B is just together, there's no other symbol between it, that's a convention to say that they're being multiplied. Agree, everybody?
Yes, sir.
All right. So let's do another example with C introduced. So we're gonna do 3 terms. So we have A, B, and C. We're gonna observe algebraic law with this. Distributive law with this. So let's say we have A outside the bracket, B is inside, but because C is introduced, we're saying it's being added to B. Right? We're going to say plus C. Right? How many terms do we have inside the bracket? How many terms do we have inside this bracket? 2, right? Because the plus means we have term 1 being added to term 2, right? If you remember, doesn't the rule say that A is going to be distributed to each term? Right? So what would we have if we're putting the A on term 1 and term 2? What would we have? Anyone?
So it would be power or...
Well, all right, let's take a step back. What if this C wasn't there? What would we have? Just A, B, correct?
Yes, sir.
All right. What if we only had C there and no B? What would we have?
AC.
So combine those two now and tell me what you have.
ABC.
A, B, correct. You have the A, B correct part.
A, B, and AC.
Perfect. That's all.
Oh.
Yeah. So you would really pretend that there's nothing else there, and you'd write what you see. So you'd say I have A, B, then I have A, C. Sounds good, everybody? Let's do one more example. What if they weren't added together? Let's say we had A bracket, my bad. What if we had A bracket, right? B minus C. Let's cover up what we have. So the first thing, what is A times B?
AB.
Right, let's write AB.
Time? Oh, yeah.
Yeah, let's write that. Then no, what is A times negative C? Let's see who can get this. In other words, if we didn't have A and we didn't have C, let's say we had 2 times negative 2, what would you get? Let me put an example below. Negative 4, right? So in other words, you put a negative sign there. So if I told you that we have now negative C, not positive C, would we still have a positive AC or a negative AC?
Negative.
Negative AC. There you go. There you go. And let's write out what we actually did. So this is for those who haven't seen it yet. So let's put simplified. So you can write this out to really explain what we just did. Right? Simplified. Look at this for me. We're gonna say A. So A times, so let me put back B minus C. There we go. Let's put what's really happening there. We have A times B, A times B, all in a bracket, right? Minus, all in a bracket again, my bad. Minus all in a bracket again, A times C. Everybody see that? So if we say A times B, that gives us what again? AB, correct? And if we say A times C, that gives us AC. But due to the fact that we have a minus sign, we just attach that minus sign to AC. And that's how we got AB minus AC. So this is how I wanted to explain it. But now we're going to introduce not only letters, but let's do some numbers along with it. Let's do step by step. Let's go. 5 is going to replace A. Put a bracket. Let's say now X is going to replace our B. And let's say a positive 3 is going to replace our negative, what we had for C. Positive 3. Take me through the steps. Before we solve anything, let's tell me what we would have as multiplication. We would have 5 multiplying the first term, right? So what would be the first term? 5 what?
5x.
So we would say 5 multiplied by x, right? What is it, the operation between the x and the 3? Plus. So I would say 5x out of this is being added to something that we don't know. So we're going to say plus, right? What is our second term?
5 plus 3.
Oh, what? 5 times 3. Excellent. So we're going to say 5 times 3. Excellent. So now what would we have as our solution? 5 times x gives us
5x.
5x, right? Plus, what is 5 times 3? 15. 15. Okay. Everybody understand how we got that?
Yes, sir.
Let's do one last example.
What if you have two negatives, sir?
Right, that's a good one. Let's actually go through that one. As Jazeel said, what if we had a negative 2x as our a? Right, we're gonna step up a little bit. Right, multiplying something that's negative inside the bracket. So let's make 3x be our b. Follow along with me. Let's make our c term be negative again. Let's say our c term is gonna be negative 4. What is gonna happen when we multiply this negative a and this negative c? Let's see. Excellent. That means you remember your operations and your terms. Good. So let's expand this. First term, oh my bad. Let's go again. First term, we're gonna go here and we're gonna say, well, the a term is what? Negative 2x, correct?
Yes, sir.
So we're gonna say negative 2x, right? Multiplying the first term. Multiplying the term that is in the bracket, the first term in the bracket. What is the first term that is in the bracket? 3x. Let's look at y. Remember that we said that
3x, oh yes, sir.
Right, because the operation determines the different terms. So if you didn't have, for example, explicit sign like addition there, then that would have been one term. But because there was subtraction there, it means you have a 3x and then a 4 separated. So we're going to say this first term is 3x. Right? Now let's do the second term, because remember the operation between it is minus. So we're going to say now the second term is minus minus negative 2x. Let's take it step by step. Minus 2x, that's the a. Okay. Right? Multiplied by what? Is it a positive or a negative 4? Remember, you only write what you see. Negative, exactly. Write what you see. Excellent. So what we're gonna say now is that, let's go down. So let's take it step by step now. So let's have the first bracket. What do we say when you have a x times x? So for this bracket, we're solving this first.
You add the x.
So you have x squared, correct?
Yes, sir.
Right? Now, so we have that x part solved. What would be negative 2 times 3? So in other words, let me write it out. Let me write it out first for those who don't see. Let's say we have negative 2 times, because you're just grouping like terms. Remember, that's a rule. Anytime you want to solve something, you should group like terms. So we're grouping, for example, the negative 2 and the 3, right? Then multiplying the other like terms, x times x, times x times x, times x times x. Right. Now, someone said for negative 2 times 2, what is the answer? 6. Negative 6, right? Okay, good. So that will give us a negative 6x squared here. Negative 6. We're going to put back the x squared. Negative 6x. Let's put a bracket here. Negative 6x squared there. Next thing. So that's the first bracket we have there. Good job. We have now to worry about minus 2x times minus 4. Don't worry about this negative sign. Let's solve the bracket first, right? So let's say minus 2 x times minus 4. Let's ignore the x first of all. What is minus 2 times minus 4?
Minus 6. Oh.
Repeat. Let me put it. So we're going to say...
Wait,
so
negative 2 times...
Negative 4.
What? Oh, negative.
Uh-huh.
Positive 8.
Positive 8. Exactly. Positive 8. Positive 8. Right? And now we can just attach back the x that was on 2, correct? Right. So all that we have now is negative 6x squared. Let's put the negative. So we're putting back the first term. Negative 6x. Negative 6x squared. Right? And here's the interesting that's going to happen. Right? Negative 6x squared. But what would be now the operation that separates the two terms? Okay? Let's see what happens. Right. And let's see why, Jazil. The reason why is because when you multiply a negative, this negative was separating the entire bracket. But here's what. Because we have two of the same negative here, right? We nullify this negative. So really and truly, me adding another negative was redundant because I am just putting back what the original sign was in the question. Let's go back to the question. The question just said I had negative 2x. So if I put another negative in front of it, that would have changed the value. You understand? So I did not need to put a negative in between here, right? Because that really is redundant since the negative is already on the 2. Everybody understand?